Math Blast 30. Show an array for 3 times 7. Use the distributive property. 3 times 7 means 3 groups of 7. And I know a group can be represented in an array as a row. So I'm going to make 3 rows with 7 x's in each row. And if I'm going to represent the distributive property here, I'm going to cut my array into 2 smaller arrays. So I'm going to draw a horizontal line here and break my 3 groups of 7 into 1 group of 7, which I know is 7, and 2 groups of 7, which I know is 14. Now when I put those together, if I add my 7 and my 14, I get 21. And so 3 times 7 is equal to 21. 2-step word problems. Kylie earned $5 for each lawn she mowed. If she had 5 lawns to mow Monday and 4 lawns to mow Tuesday, how much money did she earn? I'm going to represent this with a tape diagram. My first step in the problem is going to be 5 lawns on Monday plus another 4 lawns on Tuesday to represent the total number of lawns that Kylie mowed over the 2 days. So here, my 5 lawns and 4 lawns would be 9 lawns. Now, in the second step of the problem, I'm going to represent each lawn as earning her $5. For each lawn she mows, she gets $5. So I'll note here that this box is 1 lawn. And I know that she had 9 of those lawns. So I'm going to show 9 lawns, with each lawn being represented as a box here. Okay, and so then the total amount of money that she would have earned is 5 groups, or 9 groups of $5, which would be 45. And so I can say Kylie earned $45. Multiplying multiples of 10. 4 times 60. 4 times 60 is the same as 4 times 6 tens. And 4 times 6 is 24, and our units is tens. So 24 needs to end in the tens place. That means there's a 0 in the ones. 4 times 60 is 240. 3 times 30 is 3 times 3 tens. 3 times 3 is 9, and our units would be tens. So 9 ending in the tens place means I need 0 in the ones. The product of 3 times 30 is 90. Equivalent fractions. Shade the visual fraction model to find an equivalent fraction. 2/3 is represented in the first model. In the second model, you'll notice that each unit was decomposed to make smaller units. So I want to shade in the same amount of space in the second model as is shaded in the first model. And so here now I can see that I have 4 shaded parts out of 6 parts in the whole. 4/6 is equal to 2/3. Comparing fractions. Compare the fractions using greater than, less than, or equal. Justify using the fraction models. 1/3 compared to 1/5. Here I see that I have 1 piece in each, but the units are of different sizes. So I'll model the 1/3 by breaking my whole into thirds, 3 equal parts. I'll shade in one of those parts. I'll model the 1/5 by breaking my units into fifths, 5 equal parts. And I'll shade in one of those. And now I can see that my thirds are bigger than my fifths. 1/3 is greater than 1/5. In the second part here, I have 2/6 compared to 4/6. Here, my units are the same size. We're talking about sixths. So I'm going to break the whole into 6 equal parts. And each whole is going to be broken into 6 equal parts. So here, since I have the same size units, it's the number of those units I'm comparing. In the first model, I'll shade 2 of my 6th. In the second model, I will shade 4 of my 6th. We can see that 2/6 is less than 4/6. Appropriate metric units. Circle the most appropriate unit. A gallon of milk is most likely to hold 35 milliliters or 3.5 liters. Here I want to visualize the units we're talking about. 35 milliliters. Well, a milliliter is like an eyedropper worth of liquid here. So it would be like 35 drops of milk. A liter is like a pop bottle. So if I'm talking about a gallon of milk, I'm talking about 3.5 pop bottles would be closest. I'm going to choose 3.5 liters. A carrot is most likely to weigh 18 grams or 18 kilograms. Again, I want to visualize the units we're using here. A gram is like a paper clip. So would a carrot be like 18 paper clips? Or a kilogram is like a textbook. Would a carrot be like 18 textbooks? A carrot is most likely going to be like 18 paper clips rather than 18 textbooks. So I have chosen 18 grams. Picture graphs. Here I see a pictograph of donuts. The question is how many fewer donuts were original than donuts with chocolate and sprinkles. It's super important that I see at the bottom of my picture graph that the key, a whole donut, is representing 2 donuts. So a half of a donut, I know will be representing 1 donut. Let's look at the types of donuts that we need for the question. We want to know how many fewer donuts were original. So let's look and see how many original donuts there were. 2, 4, 6, 8, 10, 12, 14, 15 donuts were original. And I'm comparing that to chocolate and sprinkles. So for chocolate donuts, I see I have 2, 4, 6, 8. And for sprinkles, we have 2, 4, 6, 8, 10, 12, 14, 16 donuts that were sprinkled. So chocolate and sprinkled together would be 8 plus 16, which would be 24 donuts. And now original, there were 15 original donuts. So if I want to know how many fewer were original, I'm going to subtract those 15. And I can see that I would have 9 fewer original than chocolate and sprinkle donuts. Area of rectilinear figures. Find the area of the figure. Labeled measurements are in inches. That should just say inches there. So my top rectangle is a 6 by 4 or 4 by 6 rectangle. I know I could tile that rectangle to find the area. The area is the square units that cover that two-dimensional shape. So I could draw 6 columns and 4 rows, and then I could count all the squares that are created in there. And I know that 6 times 4 is 24. There are 24 squares within that rectangle there. Now for my bottom rectangle, I can say there are 3 columns and 2 rows, and I know that 3 times 2 is equal to 6. And so the area of that bottom rectangle is 6 square inches. Now if I want the area of the entire figure, I want to put those two together. I want to say the top rectangle was 24 inches squared, or square inches, and the bottom rectangle was 6 inches squared. And so when I put those together, the area of the rectilinear figure is 30 inches squared. That's all for today, Math Friends.